Alright, so this will be an introduction to my group theory playlist. Well, really, it's going to be covering all of abstract algebra. I'm going to be getting into ring theory and field theory and things like that. It's been a long hiatus, but now I'm finally back, making videos. So this video, I'll be talking about what exactly a group is, just kind of giving some basic definition and some examples, and then in subsequent videos, I'm going to be proving certain cases of, well, proving what groups are, proving certain sets which are not groups, and so on. So let's get right into it. So a group is really, you have a set with a binary operation, and that's a very abstract notion. So what exactly is a binary operation? Well, really it's something that takes two elements like A and B and it gives you a third one. So you can think of it as kind of like, you kind of put two coins in a machine, you get one coin out. That's kind of the idea of what's going on. So, but there are certain properties that these elements have to have. So for all A, B, and C in our set S, we have the A operation B is equal to C. And addition, for example, will be a binary operation. Multiplication is a binary operation. And those are the most extensively used in a lot of cases, really in almost all cases. Addition and multiplication are the operations we're concerned with. And so we have A operation B is equal to C. And we also have the fact, by the way, this property is called closure. I'll also write it over here, so it's called closure. So if we say if a set has this property, we say it's closed with respect to that operation. And so here we have associativity, where we have A operation B operation C in parentheses. Here it's the same as A operation in parentheses B operation C. Again, just think of it like addition, multiplication. Associativity is kind of familiar to people who are studying group theory because it's in linear algebra and all the other in all the lower level maths. And the third property is the existence of what's called an identity element. Now, what exactly is the identity element? Well, really, what it is where you have A, some element A times operation, or yeah, I can say times, operation E gives you A. And so let's think about it for a second. So 0 would be an identity element because if you have A plus 0, you're going to get A always. Or for multiplication, you have A times 1, it's going to give you A. So E for addition would be 0, and then E would be 1 for multiplication. So it's really just the identity. Basically, all it means is that you get the same element back. And you also have to have, every element has to have an inverse. It's important. Every single element must have an inverse in order for it to be a group. And so to make it a little less abstract again, for addition, you can have A plus negative A. That would be the inverse. And then multiplication, you have A times 1 over A because you're going to get the identity element back. Now over here, I have a fifth condition. And this condition is not necessary for it to be a group. You have commutativity. So you have A operation B equals B operation A. This is not essential for it to be a group. However, there are a lot of groups which do have the commutative property. And those groups have a special name for them, and they're called abelian groups. Abelian just means commutative. It's just a fancy term that mathematicians use. So again, over here I have some examples. I kind of talked about this one just a little bit already. You have the reals under addition. And typically you write the set, comma, and then the operation you're working with. So we say this, the reals under addition. Of course, another example would be the complex numbers are under addition. That forms a group, and I'll be proving that in subsequent videos. And the third one is probably not familiar to you. This is called a general linear group, and this really is just a set of n by n invertible matrices. Here I have 2, so this would be the set of 2 by 2 real matrices. That's why I put an R here. 2 by 2 real matrices, which are invertible. And under multiplication, these form a group. And I'll be, again, showing that in other videos. And also another example would be the rational under multiplication. So really, group theory, it's used in particle physics extensively. There are a lot of special groups of particle physics which are used, which capture properties like, spin, and electron charge, and things like that. So group theory is definitely very practical. It's used in a lot of, especially a lot in physics. But it's also interesting to study just from a mathematical perspective. So that's kind of, an idea of what a group is. And the next video I'll be giving some more examples of that and proving certain groups. So I hope you guys enjoyed this video, and I'll see you in the next one.